MSB stands for most significant bit and LSB stands for least significant bit. We have to convert into hexadecimal number system. The base is 16. Divide the given number by 16. So whenever you want to convert from one number system to another number system, there are two procedures. One is division and second one is multiplication. Hello students, welcome to CS classes. I am Ravi Kumar KR, lecturer in computer science, Vidhyaashram PU College, Temple of Excellence, Mysore. Students, let us continue our discussion with the session 2. In this session, we are going to learn the different number system conversions. As we have seen the different number system in our previous session. We have seen the decimal number system, octal, binary, and binary number system. So, what is number conversion? In the system, in this session, we are going to cover how do we represent or how do we convert the numbers or the digits from one number system to another number system. So, in this session, we are going to learn few conversion from one number system to another number system. Now, let us see. First one is decimal number to binary number system. So, this is number conversion. First, we have to convert given decimal number into binary number system, or we have to express the given decimal number to binary number system. So here, look at the example now. This is decimal number system and 53. Here in the example, the given is 53. We have to represent 53 to the base 10. So, and we have to find out what is its value in binary number system. So we are converting given decimal number to binary, or we are expressing this decimal number value into binary number value or binary number system. What is the procedure here is, students? The procedure is, first given number is 53. So here first have to divide the given number by 2. Here we have to convert this into binary. So we have to start dividing the numbers or given decimal number by 2, and we have to store this remainder. Store the remainder. Now let us start dividing 53 by 2. If you divide 53 by 2, you will get 2 2s are 4 and 13, 2 6 are 12, and remainder is 1. Here we are storing the remainder as 1. Now again, we have got 26 as the quotient and this is the remainder. Again, divide this 26, this is the quotient, by 2. So here 2 1s are 2, 2 3s are 6, and here remainder is 0. In the second step, remainder is 0. We have to store the remainder. Next one is 13, quotient, divide by 2. It is 2 6 are 12, and we are left with the remainder 1. 6 divided by 2, 2 3s are 6, remainder is 0. Next 3 divided by 2, 2 1s are 2, remainder is 1. Next 1, so 1 is smaller than this 2. So that is the reason we cannot divide it. So 2 zeros the 1, 2 zeros the 0, and remainder is 1. Here we have to keep dividing the given decimal number by 2. So because we are converting this into binary number system, in binary number system, base is 2, radix is 2, divide the given decimal number by 2 and keep storing the remainder. Once the answer is, this is the remainder we are storing, and keep in your mind, we are going to divide these numbers as long as the quotient will be less than this. So I repeat once again. So we are dividing these numbers, decimal numbers, till the quotient is less than the number 2 or the base 2. So here, now we are going to store the remainder. Now after storing the remainder, we have to keep the answer in this direction. Means from here, we should not neglect even this one. So 1, 1, 0, 1, 0, 1. So this is how we have to keep the answer. So what is the binary equivalent of this? So here equivalent is from this point, we write here 1, 1, 0, 1, 0, 1 to the base 2. This is the procedure to convert from decimal number to binary number system. I repeat, students, first method is given decimal number is 53, keep dividing these numbers by 2, and at each step we have to store the remainder. And how long we have to divide it, and we have to keep dividing these numbers as long as this 1, the quotient 1 will be less than this. So then we have to store the answer. I have to write the answer in reverse order. So from here to here. So this is from here 1, 1, 0, 1, 0, 1 to the base 2. Here generally we represent we write the base at this like this to the base 2. Here I have written here 53 to the base 10. This is to identify the numbers belongs to which number system. So here in this example, base is 2. So this is a binary number or number we are representing in binary number system. So in this example, 53, base is 10. So this is decimal number. So this is how to convert decimal number to binary number system. Now let us move on to next slide. Decimal fraction to binary conversion. So here observe this number. This is a decimal number of base 10. So this is a fractional number. So how do we convert this into binary? The procedure is this number 0.3125, you have to multiply this by 2. When you multiply 0.3125 into 2, the value you will get is 0.625. Here 0.625. If you observe 0.625 here, this 0. So this 0 we have to carry here as MSB. So this 0, what we get before decimal point, we have to store it as a carry here, 0. Next example, next one, we have to multiply this 0.625 by 2. When you multiply this, what you will get here in the, see, just to multiply this, 2 5s are 10, carry 1 here, 2 2s are 4, plus 1, 5, and here 2 6s are 12, and carry 1. So here 0 point is here. So when you multiply 0.625 into 2, you will get 1.250. So here this one we are going to store it as a carry. So this is 1. Similarly, you multiply this 0.25 or this, we have to multiply only 0.25 by 2. When you multiply 0.25 by 2, will get 0.50, and we are going to store here 0 as a carry. Again 0.50 into 2, you will get 1.0. So this 1 will store it as carry here. So here we are going to store the carry. These are the digits we get it after multiplication, that is before decimal point. So in this example, 0, 1, 0, 1 are the carry. So while writing the answer for this, here we have to write from this point, from top to bottom. So in this case, 0, 1, 0, 1. So 0.3125 of base 10 is equivalent to 0.0101 to the base 2. So this is how we represent or we convert decimal fraction to binary number. So please note down here the procedure is we have to keep multiplying the fractional part by 2. So as actually in the process, it may go for long time or it may take so many steps, but generally we stop at 4th digit. So it's sufficient for us to store 4 digit as the answer. So this is decimal fraction to binary conversion. Now let us move on to next one. It is binary to decimal conversion. So in the previous slide, it was decimal to binary. Now it is binary to decimal number conversion. So now look at the example. Binary number, this is the binary number to the base 2, which can be represented in decimal value as. What is the procedure for this? Here we have to multiply the numbers. In this example, as what you have learned in the first session, the positional values are to the power of. So this is to the power of 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3, and 2 to the power of 4. So these are the positional values, position of the each digits. Similarly, on right hand side, after decimal point, it is 2 to the power of -1, 2 to the power of -2, and 2 to the power of -3. Now observe this, it is first digit is 1. This one into 2 to the power of 4 plus second digit into 2 to the power of 3 and 0 into 2 to the power of 2 plus 1 into 2 to the power of 1, 1 into 2 to the power of 0. And similarly, after decimal point, 1 into 2 to the power of -1 plus 0 into 2 to the power of -2 and here 1 into 2 to the power of -3. When you simplify this, you will get the answer as 27.625 to the base 10. So this is how we convert from binary number system to decimal number system. Here we are going to multiply each digit by the base 2 or with the number 2. Now let us move on to next slide, that is number system conversion. Now let us see decimal to octal number system. Decimal to octal number system. So what is octal number system? A number system with the base 8 and this is decimal number. How do we convert the given decimal number 459 of base 10 to the equivalent of octal number system? Now let us see the procedure. Here again the procedure is division by the number 8. In previous example, decimal to binary, we have started dividing the number from 2 because we have to convert this into binary, because binary base is 2 and we have to store the remainder. Similarly, here we are converting from decimal to octal. Octal base is 8. So we have to divide the given decimal number by 8. And now let us see the example. So here 459 divided by 8 and here we got a 57 as the quotient and 3 as the remainder. So here 57 as the quotient, 3 as the remainder. Again the 57 by 7, 8 8s are 64. So 8 7s are 56, remainder is 1. And here we can stop dividing up to this position as we have seen in the decimal to binary. So here also we have to stop dividing, or we can divide as long as this number will be less than this number. Here 7 is less than this, or you can go for one more step, 8 0s are 0 and remainder is 7. So this is how we convert the decimal number to octal conversion, and as usually we have to store the answer as like this. So this is 713. So here 459 of 10 equivalent to, it is 713 of base 8. So this is a decimal to octal conversion. So students, what is the procedure for this? In octal number system, divide the given decimal number system by 8 and keep storing the remainder. and we are dividing the numbers as long as the quotient, this number will be less than the base number, or in this example less than 8, and we have to keep the answer in the reverse order, that is from MSB to LSB. It is MSB stands for most significant bit and LSB stands for least significant bit. From MSB to LSB, answer is 713 to the base 8. If you observe this here, all the digits are within the limit of or between 0 and 7, because 8 octal number system, only 8 digits are possible or available from 0 to 7. So all the digits must be within that or between 0 and 7. So this is decimal to octal conversion. Now let us move on to next slide, and here another type of conversion from octal to decimal conversion. Now in the previous example, decimal to octal, now it is from octal to decimal conversion. In this example, this is the octal number system, 234.56 to the base 8 here. Now again the procedure is multiplication, as what you have done in the from binary to decimal, we have keep multiply the numbers by base 2. Here again we are converting this to octal number system. We have to multiply the base of the number system, that is 8. So here, as usually, this is positions 8 to the power of 0, 8 to the power of 1 and 8 to the power of 2, and this is 8 to the power of minus 1 and 8 to the power of minus 2. Accordingly, here this first digit is 2, 2 into 8 squared plus 3 into 8 to the power of 1 and 4 into 8 to the power of 0, and plus here 5 into 8 to the power of minus 1, and it is 6 into 8 to the power of minus 2. When you multiply this, when you get the answer, here 2 into, it is 8 to the 64, 64 into 2, it is 128 plus 8 to the power of 1 is 8, 8 into 3, it is 24 plus 8 to the power of 0 is 1, so 1 into 4 is 4. 1 into 4 is 4, and this is plus, this is 5 into 8 to the power of minus 1 means 1 by 8. So, and this is 5 into 1 by 8 plus this 6 into 8 squared 1 by 8 squared. It is 8 into 1 by 64. So when you simplify all these things and when you add all these values, then you will get the answer as 156.71875 to the base 10. So this is how we convert from octal to decimal number system. Now let us move on to one more conversion, that is decimal to hexadecimal conversion. Hexadecimal is to the base 16. So given the decimal number 559 to the base 10. Here, as we have seen in our previous examples, so we have to convert into hexadecimal number system. The base is 16. Divide the given number by 16. So hope all of you know the table of 16 students. So here 559 divided by 16, quotient and the remainder. And if you know that the remainder is 15, because 15 is less than 16, we cannot divide. So this will be the remainder. So 34 is the quotient, remainder is 15. And again, divide 34 by 16, 16 2 is 32, remainder is 2. Similarly, 2 less than 16, we cannot divide. So even if we divide 16, 0, the 0, remainder is 2. So we have to keep the answer from here MSB to LSB. As I told you, MSB stands for most significant bit, and LSB stands for least significant bit. Yeah, as what you have seen in hexadecimal number system, after 9 we have numbers A, B, C, D and E, F. So here this is equivalent to 10, 11, 12, 13, 14 and 15. So here if we get 15, it is equivalent to F in hexadecimal number system. So answer would be 2 to F. F stands for 15 to the base 16. So this is how we convert given decimal number into hexadecimal number system. So next conversion is from hexadecimal to decimal conversion. Now it is hexadecimal to decimal. That is reverse of what you have done in our previous slide. So here hexadecimal number, for example 5AF dot D. This is point D. Here A is a valid hexadecimal number, F is a valid, and D are the valid hexadecimal digits to the base 16. Now how do we convert it? This conversion is, as we are converting to hexadecimal number system, we have to multiply this by 16. So in this example, this is after decimal point 16 to the power of minus 1, and this is 16 to the power of 0, 16 to the power of 1, 16 to the power of 2. So accordingly we have to multiply these digits with these numbers. So here this 5 into 16 squared plus A into 16 to the power of 1 plus F into 16 to the power of 0, and here plus D into 16 to the power of minus 1. So when you simplify this, when you see in this example, this is 5 into 16 squared, that is 256 plus, it is plus, now here A stands for 10, so it is 10 into 16 to the power of 1 is 16 plus F into 16 to the power of 0. F is equivalent to 15 into 16 to the power of 0 is 1 plus here D, A, B, C, D. It is D stands for A for 10, B 11, C 12, D stands for 13. So here this is D into 16 to the power of minus 1 is nothing but D is 13 into 1 by 16. So when you simplify this, when you sum up all these things, we will get the answer 1455.8125 as the answer. So this is in decimal number system. So this is the conversion from hexadecimal to decimal number conversion. Students, here we have learned conversion from different number system to another number system. But here only there are two procedures. One is division and multiplication. Those things you have to keep in your mind. So whenever you want to convert from one number system to another number system, there are two procedures. One is division and second one is multiplication. With the help of these two concepts, we can convert it, or it is possible to convert from one number system to another number system. Students, let us continue, or let us learn few more conversions in my next session. Thank you very much.